Good afternoon, everybody. Thank you for taking the time to join us for this webinar this afternoon. My name is Chris Chandler, and I will be your compere this afternoon. For those of you who have joined the call who don't know about Grey Matter, we've been established for almost 40 years and were founded by a group of developers, and this is something that has stemmed through our business through its existence, and really helping those developers or solution providers with access to licensing, cloud services, and technologies, with teams dedicated within our business in supporting those organizations, providing support not just from a technical perspective, but also with sales and marketing where required. In terms of our credentials from a GitHub perspective, we are a resale partner and have consultants in-house who can support that. But additionally, we are a Microsoft partner with, as you can see on the screen there, multiple gold and silver competencies. At this point, I would like to hand over to Ed to deliver the main content of this afternoon's session.
Awesome. Thank you, Chris. I really appreciate it. I'm just going to share my screen. There we go. Awesome, thank you. Let me introduce myself really quickly. My name is Edward Thomson. I'm a product manager at GitHub. I work on GitHub Actions. Today, I would like to talk a little bit about some of the amazing new features that we've added to GitHub over the last year, in particular, GitHub Actions, also GitHub Package Registry, and some of the new security functionality that we've built over the last 12 months. So again, my name is Edward Thomson. I am originally a developer. I started working on version control tools like Git before moving into a product management role and then moving over to GitHub Actions. I've been at GitHub on and off for several years now. And when I started, I would say that the core of our competency was, in fact, version control. And so fundamentally, over the course of the last decade, GitHub has become how people build software. So we have over 40 million users on GitHub. We have over 100 million repositories. And a lot of people come to GitHub and start to understand GitHub by way of open source software. So if you browse github.com, you will see almost all of the open source software in the world is built on GitHub. Here's one example. This is a project called libgit2. This is actually a project that I maintain. It does Git repository management. And the idea of GitHub is collaboration. So this is an open source project. We have collaborators from all over the world. You can see right here, we have 374 contributors. So we take, our project is entirely out in the open and we take contributions. So we'll have people raising issues when they have problems, when they need support, and people opening pull requests. So people can browse our code, understand how we've done things. They can ask questions when they run into problems, and when they find ways to improve it, whether that's adding a new feature like this one right here, opened 2 days ago, or fixing a bug, they can do that. And so this person has decided that they want to add functionality to some code that already exists, and they can actually just send those changes right up to us. And the collaboration comes in where we can talk through these changes, we can iterate on them collaboratively, and we can work together to improve this software. So this is the power of GitHub powering open source, but this is true for all of your projects, whether that's an open source project or something internal to your company. So within GitHub, we produce a lot of open source software. We've created a lot of open source software. We maintain it, we contribute to it, but not all of the software that we build and use at GitHub is open source. Some of that we maintain in private repositories, but within GitHub, we do what's called inner source. So anybody within GitHub can collaborate on projects together, even the projects that aren't open sourced. And we feel that this open source contribution model, this collaboration, is so powerful that it allows us to drive our own company with that sort of collaboration in mind, even for the things that aren't open source. So this is fundamentally the collaboration model that GitHub has built over the last many, many years. And we think that it's incredibly powerful. Our mission is to build the global platform for developer cooperation. We think that we've been incredibly successful with that. We're really, really proud of that. And some of the new functionality that we've been adding over the last year extends that collaboration methodology. In fact, one of the things that we want to do is allow you as a user of GitHub to extend GitHub itself. So the first way that we sort of, if we take a look back and kind of look at the history of extending GitHub, one of the first things that we did was to allow you to build custom applications into GitHub. So whenever anything happens on GitHub, whether you open a pull request or comment on an issue, we'll fire what we call a webhook. So you can subscribe to webhooks and listen to them. And so whenever something happens, let's say a pull request happens or a comment on an issue, we'll send that webhook to you, and then you can turn around and do something on it. Let me give you an example. You could say rebuild in an issue comment, and that could queue a new continuous integration build of a pull request, for example. This is incredibly powerful. We've seen a lot of people build some really incredible apps with it. There's a problem with that, however, and the problem is that you have to subscribe to these webhooks yourself. So that means bringing some sort of hardware to the party. So the problem with GitHub Apps is that they can be rather expensive. If what you want to do is just set up some really simple integration to GitHub, now you've got to provision a server, you've got to keep it online. You know, even using something a little more serverless can still be difficult to manage and potentially expensive. So about a year ago, we looked at this problem, we thought about it, and what we decided that we wanted to do was basically give you a platform where you could build custom tooling and applications on top of GitHub, but without needing to bring your own computer, your own computing resources to solve the problem. And we call that GitHub Actions. And the idea there was that you could take all of this functionality, you could execute all of these commands on top of GitHub events. So when a pull request is changed, when someone comments on an issue, and you can run them within GitHub's computing itself. So we'll bring the cloud to you, and you can just do whatever it is that you want to do when that happens. And we really were excited about this, and we put it into beta testing again about a year ago. And a lot of people started building sort of bots on top of it and doing things, responding to actions within GitHub, automating things within their repository. You know, for instance, you can mark issues as stale when nobody's commented on them for a little while, and maybe even close them out. So you can actually do work in your repository automatically. The other thing that people immediately decided to start doing was try to use this as a continuous integration platform and do builds. And for a certain subset of projects, they were rather successful, but we ran into problems really quickly because this was not meant as a build service, and people were really quickly running into limitations. So we realized that this was good feedback for our beta program, and we went away and we came back. And what we've done recently is we've added actual proper continuous integration and continuous delivery support to GitHub Actions. So now You can do all that integration with the custom functionality, listening to those events, but we've also added the ability to do build and test CI/CD workflows across Linux, Windows, and Mac OS. So we have these resources still available for you. So we'll bring the computing resources still. And this is all hosted in the cloud, and you can start taking advantage of this for your repositories. So again, we're still keeping that repository automation. You can still respond to issues. You can still work, notice when a pull request is labeled and do some custom action, but you can also run a build whenever somebody pushes something up to the master branch or whenever somebody opens a pull request. So let's take a look at that. Here I've got a Node.js application, and if you'll notice, I'm in the GitHub Actions beta. So you can see this beta tab right here at the top of my repository. And when I click on that, I can go through the GitHub Actions setup. What's happened is that GitHub has looked at the type of the repository that I have. It's noticed that it thinks I have a JavaScript repository, which in fact I do. It's decided that there's a bunch of JavaScript files in there, and it's asking me to set up a Node.js-based workflow. You can either set up a package if you're building a library, or I'm building an application, so I'm going to set up the Node.js workflow. And you'll see what happens is it suggests some YAML for me. YAML, of course, is the markup language that drives DevOps. So we've adopted YAML as our configuration language for GitHub Actions. And this is actually a really good default. It's just going to build my Node.js application across a couple of different Node versions and run my tests. And I'm just going to go ahead and start that commit. And when I do, the build will actually kick off. And so while that build is going, it's going to take just a minute to start and run. Let me actually look back at this YAML that I just really quickly committed, and we can talk through what it's actually doing. So this is the name of my GitHub workflow. It's doing Node CI. It's going to trigger every time I do a push. So every time either I run git push into the master branch or merge a pull request, it will run. Here it's going to run on the latest version of Ubuntu. Again, we're bringing Linux, Mac OS, and Windows servers so that you can build on them. We're going to build on Node.js 8, 10, and 12, the latest version of each of those. And then we're just going to run through this workflow. These are actually the steps that we're going to run. So we'll check that Git repository out. We'll configure the correct version of Node that we want to use. We're going to use an action that will actually do that setup. We'll talk more about what it really means to be an action in a second. And then we're going to run these commands. We're going to npm install, we're going to npm run build, and we're going to npm test. And since I committed this to my master branch, this will actually have triggered. So it will run that on push. And so I should be able to click over to actions and see what has happened. There we go. I've actually had a workflow run. And I can click into this and see exactly what it's done. And like I said, it's built on Node 8, Node 10, and Node 12. It'll just run through these steps. And if I expand here, I can scroll down and actually see my tests running. So this is the output of my unit tests. So this is going to be great for ensuring that whenever I do a push into the master branch that I haven't broken anything, or when somebody opens a pull request, I can make sure that the code builds and the code tests. So this is pretty straightforward, pretty simple. The great thing about this is I can get started really easily. GitHub Actions walked me through that setup for a Node.js. It just detected that I was a JavaScript application and walked me right through the setup that I wanted to use. The nice thing is that this is true for most types of applications. Here I've got a very different type of application. If you see here, this is a Xcode proj, and if I click in, you'll see a lot of Swift. So what I'm actually building here is a iOS application. You can see here that it's using UIKit, building some buttons, that sort of thing. And if I click on Actions in this repository, I can see that I've already set this up. I can click through to test. And what it's actually done is it's run the Xcode project, and it's running, if I scroll through here, you can see that it's running my tests. So this is possible only because GitHub Actions actually brings Apple resources to the party. So if you are a Mac developer, if you're an iOS developer, you know that you need to develop on Apple hardware. You need to be able to use Xcode. You need to be able to run this in order to run the simulators, in order to run the builds. And you may also know that you can't virtualize this. You can't just run Mac OS in a virtual machine. So we actually have to bring Apple hardware in order to do this. We're one of the only CI/CD providers that is able to offer all of these resources. And just like before, just like that Node app, it's very, very simple, very, very easy to get started. All we have to do here is say that we want to run on Mac OS, and then we're just going to run this Xcode build right here. So this is exactly the way I build on the command line. I just put it into my GitHub Actions workflow, and I'm able to build and test that way as well. I actually expect that this will get much easier. I think that we'll be building an action to enable you to use Xcode build and test without even having to know all of this command line. So as we're in beta, we're going to continue to improve that. Flipping back again, just to that Node application that I built before. Sorry, let me actually indeed flip back to that Node application. I want to make one change to it, just to highlight one of the really cool things that I like about GitHub Actions. So I mentioned that we're running we're running our builds and our tests on Node 8, Node 10, and Node 12. The way we're doing that is we're using what we call a matrix. And so this is basically just variable substitution. So I set up these variables right here. So down here in my steps, in my workflow, node version is going to be substituted for 8, and then it'll run through, and then for 10, it'll run through again. And that's how we were able to build and test on all of those different versions. We can take this a step farther though. We can actually have multi-dimensions in our matrix. So I don't have to define over and over again the steps. I can just reuse these same steps, and I can build on different platforms, different operating systems, as well as different node versions. So I can add a new variable to my matrix. I'm going to call this OS, and I'll give it the different operating systems that we support in GitHub Actions. There we go. And now, again, this is just variable substitution. So instead of runs on specifying Ubuntu latest, I'll use my variable and set up the matrix.os. And I'll go ahead and commit that. That'll start another build. And now what'll actually happen is for each operating system, it will run each of these node versions. So I'll actually get 9 builds. I'll get node 8, 10, and 12 on Ubuntu, 8, 10, and 12 on Windows, 8, 10, and 12 on Mac OS. And so if I click over into Actions, you should be able to see that. We'll actually watch this build as it goes. And what it's doing right now is it's starting to get my source, and it's gonna set up node and then actually run my tests. And right now, this tab is doing that on Ubuntu with node 8. And I can just click through and see it's doing this on all these. I've got 9 builds going on right now. So it's really, really easy to get started with expanding your sort of matrix of supported platforms. So I'm able to really quickly get confirmation that my build runs everywhere and my tests are running everywhere. So you can see that and you can understand how this protects you. If I go into a test, let's look at this particular arithmetic test right here. If I scroll through, I can understand a little bit about what's going on here. And let me just go ahead and edit this. Let's invalidate this test. I certainly expect this to reject that and give a 400. If I change this to get a different HTTP error code, I would expect this test to fail. This is obviously a very contrived example, but I think it highlights the importance of going through continuous integration. So I've checked that into master. My build has been queued. If I click on this, what should happen now is once this starts, it will check my source out from my Git repository. It will run the build, run the test, and they will in fact fail. So I get very quick response, very quick information that I've actually broken my project. This is even more important if you set it up to monitor pull request builds. So as a pull request is submitted, you'll get quick feedback that everything is working or everything is not working very quickly. And of course, in the power of live code, I actually did not break my test. We'll have to circle back to that. But again, the importance of running unit tests means that I'm always confident that my master branch is healthy and able to be shipped, and that my that pull requests coming in, I have a very good feeling about the quality of the code because they're running my tests every time they run. I've talked a lot about continuous integration, build, and pull request validation tests. Another thing that I think is incredibly important is repository automation. That was the original idea behind GitHub Actions. It was the original problem that we wanted to solve with it, and we haven't forgotten about it. Repository automation is one of the most important things that you can do as a maintainer of a project, whether it's an open source project or something that you use within your company to help you scale, right? You can use you can build custom tools, you can use actions that already exist to help you deal with the number of issues that you have, the number of pull requests that you have. And GitHub Issues, I think, is very effective for doing that. Let me give you a very, again, contrived example. Let's say we want to bring a little levity, to this issue. Let's say that this issue is getting a little bit serious. You can see that it's very serious already. But I want to actually bring a fun image in when things get a little too serious. And so what I'm going to do is type /Octocat. The Octocat, of course, Mona is the mascot of GitHub. And when I type /Octocat in an issue comment, what I actually want to do is post an image of Mona. And what I've done here is I've created a custom GitHub action to do that. So a GitHub action is just a piece of code. It's a reusable piece of code. It lives in a GitHub repository, and it will respond to a webhook, just like the GitHub Apps that we talked about earlier did. Whenever something happens in my repository, this GitHub action is notified. And you can look at this. This one's written in TypeScript. you can see that it's very, very simple. Whenever there is a command that says /octocat, like the one that we just put in that issue comment, it'll run some code. And in this case, it will, find a random picture of an octocat, and it will create a comment on that issue with that image. So you don't necessarily need to understand this code and what it's doing, but the idea here is that we can build code around events that happen on GitHub. And in this case, we have octocats in our issue timeline. Of course, this could be a lot more advanced or mature. You could type again /rebuild and queue a new build on your continuous integration system. You could, based on a label, you could change assignees because you've written a GitHub action that understands perhaps the areas of your code and who should be assigned based on how labels are opened. And again, these are reusable. So if I actually look at the workflow in this repository that's driving this, what happens is on issue comments, anytime somebody comments on an issue, what is going to happen is we're going to run this particular GitHub action right here. It's the one that I just showed you in this repository, eThomson/Mona action, eThomson/Mona action. So you're able to use custom actions that can support your workflows within your repository. So the other nice thing is that you'll see this within the GitHub Marketplace, that we have actions in the Marketplace. So this is a way to extend your repository automation using these actions. Here's an example: label approve pull requests, assignee to reviewer. So these actions are actually able to automate workflow within your repository so that you don't have to do as much, so that you can allow GitHub basically to help you build your software. So that is one of the incredibly important things that we've been building over the last year. Another exciting tool that we've been building within GitHub is what we call GitHub Package Registry. So we've, earlier I showed you collaborating on source, opening issues, opening pull requests. One of the things that we want to enable you to do is collaborate with packages as well, with built code. And that's where the GitHub Package Registry comes in. So we're able to take your built code, whether that's an NPM package or a Ruby gem. If you're a .NET user, you might be building NuGet packages. Java users are probably creating Maven packages. And everybody in 2019 is looking at containers, I think, and Docker. So we have the ability to create either a public or a private package registry and allow you to publish into it. Why is this useful? Let me give you a concrete example. If I am building Docker containers, I may want to put my final finished product on Docker Hub. But while I'm doing development, if maybe I want to be able to run nightly Docker containers. Maybe I want to create a Docker container on every commit and be able to actually run that and test it, deploy it to a staging server, something along those lines. But I don't want those actually on Docker Hub until we release. I can use GitHub Package Registry as my private location to do that testing. Let's take a look at the package registry. Here I've got, again, this is my Node.js app from before that we set up the action on. Right here, I can go to packages and I'll see that I have a Docker package. And if I click on that, it will show me that I'm able to, it'll give me instructions on using it. It'll give me instructions on extending it. And this is all within GitHub, within GitHub's package registry. So we've got a CDN set up so that it's nice and fast. And this is set up as a public repository, but it could also be private within your organization. So this could be and it's going to use the same authentication that you use with GitHub. So it's a very easy way to set up a private package registry. The thing that I think is particularly cool about this is that it integrates very, very nicely with GitHub Actions. So I can use GitHub Actions to not just create a build and then run the tests on it. I can actually use GitHub Actions to create a Docker container that contains my built product and even push it up to the package registry. So let's take a look at what that looks like. If I go back to my workflow, let me get rid of all those operating systems. Sorry, let me click edit on that. I just want to do this on Ubuntu latest, and I'm going to just use a single node version, right? I don't need 9 builds here all pushing up to the Docker registry. I just want one. And so what I'll do down here is, instead of running npm install and npm run build and npm test, I'll actually do my Docker packaging. So I will log into the GitHub Package Registry. And what I'm going to do is actually use a secret that I've already got configured. I didn't want to show you my secret token. I'm sure you're all very trustworthy, but still, I think it's probably a best practice that I keep that nice and secure. Then what I'm going to do is just run docker build and tag it. This is actually, if you remember what we just saw, that this is actually the tag that it suggested for me on the packages tab. And finally, I'll run docker push. And what that will do is create my Docker container and then push it directly into GitHub Package Registry. Sorry, missing one line. What I did was pushing a particular version. So let me actually set a new version, and we'll do that based on, we'll use a Unix timestamp. There we go. So what we'll do is, this is a great way to build a Docker container every time we push something into the master branch. So again, what's going to happen? It's going to log into the GitHub package registry. It's going to do our build, and then it's going to push that built Docker container into the package registry. So let me go to Actions. We'll see that in progress. There we go. And so we can actually expand that out and see these steps running. So we do get a live log of exactly what's happening at any point in time. One of my favorite things about GitHub Actions is just watching it go. And so you can actually see now it has logged into GitHub Package Registry with Docker. Now it's going to go ahead and build that container. So now, if I open up the package tab, if I navigate through, right now we're at version 1.0. This was a version that I had already uploaded. You know, this is what we saw when I navigated through. If I go back to my action, we'll see that once this finishes up, it will actually push a new version, and that version is going to be based on the sorry, it's going to have a version number that is based on the date. So this takes just a minute because it does have a lot of dependencies it's pulling down and that sort of thing. So in the meantime, let me go ahead and pull this version down locally so that we can see what this looks like. So I've already done the Docker login. So now done that on my local machine. So now I'm able to do the Docker run, and it's going to pull that down from GitHub Package Registry and start it up. I'm sorry, let me actually expose a port so we can actually see the web app running. And now if I go to localhost port 3000, there's my calculator app. And it actually can do some calculations. 45 plus 45 equals 90. Looks just like the sort of pocket calculator you had, well, I had when I was a kid. I realized that, you know, in modern times, people are doing calculations on their fancy mobile phones. Right. So that's actually still running. It's actually just now pushing up to the Docker registry, since I'm depending on some big things, some big base packages. It does take just a second, but it looks like it's just finishing up. And so now if I go back to my package and reload, indeed, I've got a totally new version number loaded up there. And so what I'm able to do is use just the absolute latest version of my software from master. So what happens is every time I do a push, it'll run a GitHub action. That GitHub action will push up to the Docker registry, and ultimately it gets loaded there into the GitHub package registry. So it's that private registry. So ultimately your end users aren't seeing this, but any developer can pull just the latest version of a GitHub application. Very, very cool. It's a great way to collaborate on built software, collaborating with packages, whether that's an NPM package or whether that's an NPM package or a Maven package or that sort of thing. So here we go. Perfect. The last thing I want to cover is some of the security tooling that we've added to GitHub over the past year. So one of the important things while you're building software, while you're deploying software, is keeping it secure. And one of the things that GitHub wants to do is automate as much of the difficult pieces and the more mundane pieces of software development as possible. And around security, it's very easy to miss the fact that there's been an update to a piece of software that you depend on, and perhaps it's not secure anymore. So GitHub can help you do that. We have a database of known vulnerabilities, and we can look at your software, understand the dependencies that you're using, and let you know if any of those dependencies have an insecure release. And ultimately, we can alert you. We can tell you that there's a piece of software that you use that has a vulnerable dependency. This is actually how one of the larger data breaches in history, the Equifax breach, occurred. They depended on a piece of software that had a security vulnerability. And once that vulnerability was known, people just started looking for websites that used it and ultimately found Equifax. And that's why my social security number is now in the hands of some hackers. It's not cool. GitHub can help you with that. We can tell you, we will just let you know right within your repository that we found a potential security vulnerability. We'll only tell you, we'll only tell the people that maintain a repository, and you can click to see that information and understand how you might mitigate it. Now, I think that's really helpful, but what's, I think, much more helpful is that we take it a step further. Instead of just telling you that your software may be vulnerable, we can actually fix it for you. We can send a pull request to fix the issue just automatically so that you don't have to worry about it. Let me show you how that works. So again, we're in my calculator repository. It is a node.js application. And I've got a slightly older version of this software that depended on a particular NPM package that actually has a security problem. And so GitHub is telling me that right here with this yellow bar. So let me click on that security alert, and we can dig in to understand what's happening. In fact, it's a critical severity security alert in a package called Lodash. I can click on that to see more information. And apparently versions of Lodash prior to 4.17.13 had a security vulnerability. It's asking me to upgrade to the latest version. I can actually see the CVE. CVE stands for Common Vulnerability and Exposure. It's the clearinghouse where security alerts happen. And I can get a lot more information about the problem by clicking that. But I can also just click Create Automated Security Fix. I can let GitHub fix this for me. So this is a tool called Dependabot that GitHub has acquired. And what'll happen now is that Dependabot will send a pull request updating my package JSON to the latest version. And so it's doing that right now. While it's doing that, let me click back to alerts and point out one thing. So what is off, and this is off by default, is automated security fixes. I can turn this on so that instead of me having to navigate to my repository, see that yellow box that says that there has been a security problem, I can let GitHub handle it for me completely automatically. So now whenever there is a security problem, Dependabot will just send me a pull request. So instead of having to navigate and see the box, I'll actually get an alert that Dependabot has opened a pull request against me, trying to fix it, and I can just go review it and merge it. And again, because we like automation, I don't even have to do that much in the way of review. This is a different repository where I've already let Dependabot do its magic. Let me click on pull requests because it's still processing on that other repository, but this is what it will produce when it's done. It will send a automated pull request with a bunch of information, bringing the version of Lodash up to different versions to see how far it can get. So I was at 4.17.11, it tried 12, that worked, tried 13, and just kept going until the latest version. And it's decided that that is a safe place to send that pull request. So now I can review this pull request, understand what's changed, and I can see that it's removed version 4.17.11, updated to 4.17.15. But the best part is that since it opened a pull request, it's also run those GitHub Actions against that. So it's done a build against my entire matrix of versions. So it's done a build against Node on version 8, version 10, and version 12. So I have really high confidence that Dependabot has done a good job. So Dependabot has analyzed this, and now I've actually run my build and my tests against this new version of Lodash. So I can confirm that, and now this will go through, this will build a Docker package that I can then deploy. And so I've got end-to-end a lot of confidence about everything that that GitHub has produced for me. So that, in a nutshell, is some of the exciting new collaborative tools that we've built at GitHub over the last year. GitHub Actions and GitHub Package Registry are still in beta. We'll continue working on those throughout the year, and we'll see them launch at GitHub Universe in November. We're really excited to bring those to you. If you want to get early access, you can sign up for the beta now. You can get more information on Actions and GPR at github.com. You can sign up for the beta for Actions at github.com/features/actions. And I don't see any questions, but if you come away with some, if you think of some questions over the course of the watching this again, or as you reflect upon it, feel free to reach out to me. The best way to reach me is on Twitter. I'm eThomson, that's ETHOMSON. And again, feel free to get in touch, and I'm happy to help. So thanks so much for your time. I really appreciate it.